So hello everyone. Since JEST 2026 exam is tomorrow, in this video I will solve some very interesting concept based questions from JEST 2024. These are not just problems but the questions that can really sharpen your thinking, okay, for tomorrow's exam. ठीक है? Along with that, I will also share a few last minute strategies and tips that can help you to maximize your score for tomorrow. Okay, so these are the problems. Okay, remember that exams like CSN, NET, GATE, JEST are not just tests. Okay, they are milestones basically. When you qualify these exams, so when you qualify these exams, you will definitely feel proud of yourself, okay, and your journey for physics. Okay, so stay focused and stay calm. So the first question is that here I am discussing some important concept based questions. Okay, A and B 2 cross 2 Hermitian matrices and small a1 small a2 are two linearly independent eigenvectors of A. If a1 and a2 are eigenvectors of B, then commutation of AB is 0, and statement 2 is if commutation of AB is 0, then a1 a2 are eigenvectors of B. Okay, so which statement is correct? Okay, firstly, if we take small a1 small a2 are the eigenvector of B, then we can write down in this way, and also this small a1 small a2 eigenvector of A, then from this we can show that commutation of AB is equal to 0, and it will be also applicable for commutation of AB when apply when state A2 also. Okay, so first statement is always true, but statement 2 is false, because if AB commutation of AB is 0, it is not necessary that small a1 small a2 will be the eigenvector of B matrix also. Okay, this is not necessary. If a1 a2 eigenvectors of A and B, then commutation of AB will be obviously 0. Okay, so you have to think carefully to solve this type of question. Okay, so then a classical system has following action. So Q is the generalized coordinate, alpha beta constant, which the following statements true about the dynamics. So we know that action S is equal to L dt. From this, if we carefully do the Lagrangian equation of motion, we will see that Q double dot equal to 0. This is the equation of free particles. Okay, this is the dynamics of free particles. So this dynamics does not depend on alpha and beta. Okay, then next question, a quantum harmonic oscillator with energy levels n plus 1 by 2 h cut omega, okay, is in equilibrium at low temperature T, so that occupation of all states with n greater or equal to 2 is negligible. What is the mean energy of oscillation? Okay, this is very interesting question. For n equal or greater than 2, all states are negligible. So we know that probability is this, like that for n equal or greater than 2 is negligible, means this should be equal to 0 or nearly equal to 0. So from this we can see that this e to the power minus 5 by 2 beta h cut omega for n greater than 2, all terms are 0 in probability. Okay, so when we write the partition function, full partition function, only first two terms for n is equal to 0, n is equal to 1 will contribute. Okay, so partition function is now like that, and we have to be careful. Okay, to solve any question, always scan the option first. If you solve just from Z and calculate E average from this Z, okay, from this Z, you cannot find out the actual option. Okay, so you have to be careful and always scan the option first before viewing any problem. Okay, so then if you take jet as usual this and calculate the E average, you cannot find the actual option. So you have to be careful about this. So to match the options, I just take common of these terms and just calculate. Okay, then I am getting this answer and option is this. Okay, and if you calculate from this jet, you will not definitely get this option. Okay, so you have to be careful about these things, because basically JEST net exams are for a JEST net exam. You have to be careful about these things also to match the correct option, to scan the option first before solving the problem. Okay, then a particle moving in a one dimensional has wave function this expectation values of momentum. We know that if the wave function is real, expectation value of momentum is 0, and if wave function consists the imaginary part, we get finite expectation values of momentum. So for psi, I just expand this wave function, and we see that this part is real and this part is imaginary. We know expectation value of momentum of any real wave function is 0. From this, we just operate p from this on this psi, and we get, okay, in this way you get expectation values of 2h cat k0. So to solve this type of problem, we have to be careful that expectation values of momentum of any real wave function is 0, and we have to take only imaginary part of this wave function carefully and solve this problem accordingly. Okay, let p, small q and small p be the canonical phase space coordinate of a system where q is the generalized coordinate and p is the generalized momenta. Capital Q is equal to small q square, transformation of generalized coordinate. Which of the following function canonically conjugate to q? So for canonical conjugate, we have to show capital Q, capital P Poisson's bracket equal to 1, and we have to take this fourth option and have to match that which option is 1, which option Poisson's bracket gives 1, and I get the fourth option is right. Okay, so it is not difficult question, but you have to be remember this type of things to show canonical conjugate momentum capital Q, capital P Poisson's bracket is equal to 1. Okay, then next problem is GP is this and f of x is 1 by root over mod of x, then correct form of GP. I just substitute this fx in this way, and for minus infinity to 0 this f of x mod of x is minus x, and for 0 to infinity this is plus x, and then if we take minus x is equal to y, and this equation basically reduce to this. From this first part of the integration I am getting this, and then just added these two equations. Okay, so let's substitute equation just. So the integration of 0 to infinity cos y by root y dy is a constant. This is beta. So correct option is this. So this is not difficult question. Just you have to put f of x in this equation, and just you have to do carefully about this substitution and all these things. Okay, then you will get definitely right option. This is not difficult basically, but in exams all you have to be careful and consistently find out the actual options of these questions. Okay, you have to be careful. Okay, in exam hall also. And then next question, what is the power of light source emitting photons of wavelength 600 nanometer at a rate of 1 photon per second at power is equal to W by T, at W is equal to hc by lambda for photon of light source, and rate of 1 photon per second. So n by T is equal to 1, and I get hc by lambda. So from this equation I get power P is equal to this. This is not difficult question, but this is easy question. Okay, basically, and you have to solve this easy question first in your exam. Then next question, given that latent heat of liquefaction is 80 calorie per gram, what is change in entropy when 10 gram of ice at 0 degree Celsius converted into water at same temperature? Okay, so this is the first order phase transition. Latent heat is 80 calorie per gram. So delta S is equal to dq by t, and as temperature is fixed, but state is changing. Okay, so ml by t. So from this equation I can get this result. Okay, then consider a system of n non-interacting spins half atoms subject to a magnetic field with Hamiltonian is given by this. G is the Landau factor, mu be Bohr magneton. The system is in equilibrium at temperature T. Okay, what is the probability that jet component of the spin corresponding to given atoms have the same value? Okay, so basically we have two atoms, and if we take S1 S2, their corresponding jet component spin. Okay, when two spins are same one, plus 1 by 2 plus 1 by 2, we get energy this. When two spins are minus 1 by 2 minus 1 by 2, we get energy this. When two spins have different value, 1 by 2 minus 1 by 2 and minus 1 plus 1 by 2, we get energy this. Okay, so this is from this equation. I just put value of S and get the answer of energy. Okay, then question is asked, what is the probability that jet component of spin corresponding to given atoms have the same value? When two atoms S1, S2 have value 1 by 2, 1 by 2, or when they have value minus 1 by 2, minus 1 by 2. Okay, so this is the equation. Okay, from this, when they have two atoms have same jet spin value, okay, and corresponding this, I am getting this result. Okay, the energy spectrum of a system of spinless non-interacting fermions, and 1 second, and you have to practice this type of questions much. Okay, more and more. Basically this type of questions oftenly asked in CS and NET JEST frequently. Okay, this type of questions, very common question but good question. Okay, then another statistical mechanics problem. The energy spectrum for a system of spinless non-interacting fermions consists of n plus 1 non-degenerate energy levels. Okay, and x is equal to 2 power minus beta epsilon for n identical fermions in thermal equilibrium at T. What is the average occupancy of highest energy level? So for average occupancy of highest energy level, I am calculating. Okay, from this I am getting this result. Okay, but option is like that. Okay, I don't know what is the mistake of me. What is my mistake? I don't know. Basically, you have to check. Okay, by yourself. But method is like that. Okay. Then a two-level quantum system has Hamiltonian this at T0 system is in state psi 0. What is the earliest time t greater than 0 at which sigma z is this will yield the value minus 1 with probability 1. Okay. So this is the question, very interesting question. You need to practice these questions more and more. Basically, system is given at t is equal to 0 initial state, and earliest time at which sigma z when measured yield a value minus 1 with probability 1. We have to find out the earliest time. Firstly, the initial state, we can write down the linear combination of eigenstate of this Hamiltonian. Okay. Then from this equation you can find out C1 and C2. Okay. Then when we know that if state at psi is equal to 0, state can move at time t to the power minus int h by int by h cut into psi 0. State moves in this way, and 1 by root 2 corresponding energy h cut omega 0 and 1 minus 1 eigenstate corresponding to energy eigenvalue minus h cut omega 0. Okay, I just substitute this at psi t And question is asked, at which sigma z will yield the value -1 with probability 1. So sigma z have two eigenstate 1 0 0 1, 1 0 corresponding eigenvalue +1, 0 1 corresponding eigenvalue -1. So probability is this. Okay. So what is phi here? Phi is 0 1 basically, which corresponding to eigenvalue -1, and psi t is this. Okay, psi t. C1 C2 we know C1 C2. This is the psi t basically, and phi is basically 0 1. So we are now calculating this probability now, and this probability should be 1 when it will be 1 for earliest t when t is equal to pi by 2 omega 0. Okay. So again this question is very interesting, and frequently they asked in different exams, CSI, NET, GATE, JEST, also TFR also. Okay, firstly you have to write down the initial state in the superposition of the linear combination of two eigenstates of this Hamiltonian. Then you can evolve psi t using the rule, and then this is the final probability equation. Okay. Okay. Next question, a system of two non-interacting identical bosons, each in thermal equilibrium at temperature T. The particle can be in one of three states with non-degenerate energy eigenvalues -epsilon, 0, epsilon. Okay, but two bosons and three non-degenerate eigenvalues possible. And average values of each -n by 35 epsilon. What is the values of n? So to do this problem, firstly you need to calculate energy for two bosons and three energy levels. Okay, when two bosons are present in this way, energy we get -2 epsilon naught. When two bosons, no restriction. Okay, for bosons we have no restrictions of their seats. Okay, so in this way we can find out different energy levels, and then we can find out the actual partition function gi e to the power minus beta epsilon I. This is the degeneracy. Okay, from this equation we just calculate average energy, and it is given that e to the power minus beta epsilon not equal to 1 by 2. You have to careful to when you are solving this type of calculation, just put and do this calculation carefully, otherwise you will get wrong result. From this I am getting n is equal to 36. Okay, so this type of problems are frequently asked in GATE exam. Okay, again and again. So you have to be careful when calculating this type of problem. Okay, next question from mathematical physics. A rotational matrix is given. Phi is the angle of rotation. We have to find sec square phi. For rotational matrix, you always know that trace of rotational matrix is equal to 2 cos phi plus 1 when phi is the angle of rotation. Okay, when phi is the angle of rotation, so trace of r is equal to 2 cos phi plus 1. From this cos phi is equal to 2, so we can find out sec square phi. Okay, next question, consider a particle of mass m and non-zero angular momentum L subject to central force Vr. What is the radius r at which it can have circular orbit? Will the circular be stable or unstable? Basically, to do this problem, first we have to find out the effective potential, which is central potential plus centrifugal potential, and then find out the radius of a circular orbit. dV effective dr is equal to 0 or r is equal to capital R. From this equation you can find out the radius. Okay, and for us to check the stability, d square phi d effective r square, if this term is greater than 0, we get stable circular orbit. If it is less than 0, we can find the unstable circular orbit. So from this equation I am getting greater than 0, so this is the stable circular orbit and radius is this. Okay, good. This question is frequently asked in JEST exam. Okay, so do this problem carefully. Then okay, question is given, a matrix is given which is singular matrix, mention this. A commute with B and we have to calculate eigenvalues of A. So firstly I blindly try to solve the eigenvalues of A. Okay, blindly try to solve, but then I noticed that from these options that when I add these options eigenvalues, the second B option give 14 sum of eigenvalues. Okay, and we know that sum of eigenvalues is a trace of matrix and determinant of eigenvalues, sum of eigenvalues is a trace of a matrix and determinant of a matrix is the product of eigenvalues. Okay, so we, without doing any calculation, if we add the sum of eigenvalues, option B gives 14 and trace of this matrix is 6 plus 6 plus 2 is 14. Okay, so that is the reason I am always telling you that always scan the option first before doing any problem blindly. I also did firstly this problem blindly. Okay, but then I noticed that sum of eigenvalues option B gives 14 and trace of this matrix is 14. Okay, so from this we can easily say that B is the correct option. No need to check the exact eigenvalues of this matrix A, and no need to show the commutation relation of B or things like that. Okay, so you have to be careful and always scan the option first before doing any problem. This is my opinion to you. Okay, then okay, I think this is the next question. Okay, last question, not next, this is the last question. A particle with energy E greater than 0 incident from right, okay, on a one-dimensional potential composed of delta function, barrier at x0 and heart wall at x minus n. Potential profile is given and k square alpha beta is given. Okay, the particle reflects from the barrier without any phase shift. Okay, which of the following transcendental equation determines its energy? Okay, it is not difficult question, but it is time taking question. Okay, in exam hall I will prefer not to do this type of question. Basically, if you are confident about yourself 100%, then do this question, because this type of question is time taking but very interesting question. Okay, two tricks is important in this question. One trick is that particle is coming from right to left, and second trick is that the particle reflects from the barrier without any phase shift. Okay, and which option is correct? Firstly, potential profile is this like that. For first region we get wave function psi 1 this. For second region we know at x is equal to minus a, and this region wave function is 0. Why? Because wave potential is infinity at this region. Okay, so we have to be careful about the boundary conditions. So psi 2 is this and psi 1 is this, and then we know that at x is equal to 0 psi 1 psi 2 continuous. From this equation I am getting this, and we know that at x is equal to 0 in delta function potential, first derivative of wave function is discontinuous. From that limit we can find out this boundary value. Okay, so from this I am getting this. Okay, and also mention that the particle reflects from the barrier without any phase shift. Okay, without any phase shift means in the first region a I to the power ikx plus b to the power minus ikx, this is the incident wave, this is the reflected wave, without any phase shift means A is equal to B. Okay, otherwise um, this violate this lines without any phase shift. Okay, so this is very tricky question basically, and you have to be careful and consistent throughout this question. If you confident to do these questions in exam, then do it, otherwise it will take much time to think these things. Okay, then I just substitute and put this value. Okay, and A is equal to B as without any phase shift. From this, just doing calculating these things and then doing, I am getting this result. Okay, this is my correct option. So option B is the right answer. Okay, but this type of questions basically frequently asked in CS and NET exam in part C. Okay, in 5 marks part C in CS and NET exam, they basically asked this type of questions much more and more. Okay, so if you confident to do these questions carefully and confidently, then do this, otherwise it will basically time taking. Okay, so now I am telling you some tips and strategy to maximize your score in tomorrow's exam. Okay, so when you bring a question, understand the question deeply. Okay, and do not overthink in the exam hall, and do not solve any question blindly. Always scan the option first, then try to solve. Okay, because this type in JEST exam, you need to careful and need to always scan the option first. Okay, and do not waste time in one problem. If you stuck 5 or 6 minutes of any problem, just leave it. Okay, and self-talk is positive, and you talk yourself that you can talk yourself that that I am not here to solve everything. Okay, I am here to maximize the correct answers. Okay, this is the main motto of our, okay, to crack any exam. So all the best for your JEST exam tomorrow. So bye.